Hello everyone, welcome back to my channel. Today I'm diving into day 1 of the 5-day Gen AI intensive course with Google and Kaggle. I'm excited to share the first set of assignments with you, including some fascinating insights into foundational models and prompt engineering. Let's get into it. For today's assignments, I'm starting with the intro unit called Foundational Large Language Models and Text Generation. First, there's an optional podcast episode created by Notebook LM that gives a summary of the unit, a great way to get a quick overview on the go. But the main task is reading the white paper on this topic, which dives deep into the fundamentals of large language models, including the evolution of transformers, fine-tuning, and techniques for inference acceleration. I'll be breaking down my key takeaways and practical insights of you as I go through the material. Next, we dive into Unit 1 on prompt engineering. Again, there is an optional podcast summary by Notebook LM, which is super handy if you want an audio overview. But the main highlight here is the white paper on prompt engineering. This is all about learning the best techniques to get optimal responses from large language models, which is a core skill in AI interaction. The white paper titled Foundational Large Language Models and Text Generation dives deep into the fundamentals of large language models and their architecture. It starts with an introduction to why large models are important and then takes us through the core architecture of transformers, covering everything from input preparation to multi-head attention and self-attention mechanisms. Each part is explained in a way that shows how these components work together to make LLMs so powerful. It's fascinating to see the evolution of large models. The white paper includes landmark models like GPT, BERT, Lambda, and the more recent Palm and Gemini. For each model, we get insights into the unique techniques and breakthroughs that make them different, helping us understand the progression that leads to the high-performance LLMs we see today. Another critical part is fine-tuning, the techniques that let us customize an LLM to handle specific task or domain. This section covers various fine-tuning methods like supervised and parameter-efficient techniques. This is super valuable for those of you interested in using and even customizing AI models effectively. To make these models more practical, the white paper also discusses ways to accelerate inference. It covers optimization methods that make AI efficient without compromising too much on quality. Finally, we get into real-world applications like machine translation, text summarization, chatbot, content generation, and even multimodal uses. This is incredibly useful for those of you looking to build projects with LLM or explore what they can do in various industries. Next up, I'm diving into the prompt engineering white paper, which offers essential insights for anyone looking to master prompt crafting with LLMs. One key message is that prompt engineering is for everyone, not just data scientists. But crafting effective prompt does involve skill, and this white paper breaks down the various aspects that can influence a prompt's success. Everything from word choice and structure to model configurations like temperature. The white paper takes a deep look at LLM output configurations, including factors like output length, sampling controls, temperature, and top K and top P parameters. It's fascinating to see how adjusting these settings can change the model's response and help us achieve specific outcomes. We then get into the core computing techniques such as zero-shot, one-shot, and few-shot prompting, along with advanced approaches like system, role, and contextual prompting. These techniques allow us to shape model responses by providing just the right amount of context or role-based instructions. The white paper also covers advanced techniques like chain of thoughts, tree of thoughts, self-consistency, and react. These techniques are especially helpful for complex tasks as they encourage the model to follow a long chain of reasoning or take intermediate steps toward generating a solution. For those working with code, there's a section dedicated to code prompting, which covers writing, explaining, translating, and debugging code with LLMs. There's even a part about multimodal prompting, exploring the potential to prompt with images alongside text. Finally, the white paper shares best practices like providing examples in prompts, designing with simplicity, and experimenting with output format. Here are the couple of examples that illustrate how much impact a well-crafted prompt can have. In the first example, I'm visiting New York right now and I would like to hear more about great locations. I'm with 2 3-year-old kids. Where should we go during our vacation? But the rewrite includes act as a travel guide for tourists. Describe great places to visit in New York, Manhattan with a 3-year-old kid. This change makes it clearer and more specific for the model, leading to more tailored and helpful recommendations. Let's look at another example. Generate a 3-paragraph blog post about the top 5 video game consoles. The blog post should be informative and engaging, and it should be written in a conversational style. Do not write, generate a blog post about video game consoles. In this example, the do prompt provides clear guidelines on tone, structure, and content length, ensuring the model knows exactly what's expected. So let's start with our day 1 prompting code. So here the instructions about Gemini API and Vertex AI is given, and also some of the instructions with respect to how to start the code with the Kaggle notebooks. You have to make sure that your phone verification is done. In case if it is not, you have to complete it. So in the welcoming mail, we have already received how to generate the API from Gemini API. So I have already generated API code for that. So here I will be attaching that code. So I have to click on add-ons and select secrets, and here I'll be attaching that Gemini API over here. So once the process is done, I will be installing the SDK and then importing some of the files that are necessary for my code. So here my Google API is successfully added. So next here you can see there are some of the generative models which is already there and some content which is already given. So the model which is selected is Gemini 1.5 Flash, and the content is explain AI to me like a child. So here you can change the prompts and you can check how the responses are. And here in this line, you can check how the output can be provided in the form of markdown. So let's now have a start with the chatting process. So here you can see I have started my chat. So let me change the name to my name. So the response you can see here, hello Swapna, it's nice to meet you. What can I do for you? So now I would like to send a message to the LLM. So can you tell something interesting about aeroplane? So after this response, I want to check whether the model is retaining the memory or not. So you can check I have asked my name again. What is my name? So it has said the right answer. Of course, I remember your name. It's Swapna. I'm still here ready to chat about aeroplanes. So it's good to see that I'm having a conversational chat with an AI. And next is you can choose a model. It is not necessary you have only one model. You have many models over here. So once you run this code, you will get a list of models over here. And I would like to select here Gemini 1.5 Pro model. So here you can see I have got a complete information with respect to this model based on its version, display name, description, input token limit, output token limit, and generation methods, temperature, maximum temperature, top P and top K. So it is already set, but in case if you want to change it, you can change it. We will be seeing in the later on code here. So here you can see we can change the token length. So here already it is 200. And I would like to change it to the 500. So you can check the output for 500. Now let's come back to the output of 200. So you can check the output for the 200. Even you can change the content generation also. Though you have said it is 1000-word essay, but still The maximum output tokens is selected as 200. And here you can check there is a short poem. I would like to change it to with respect to the pizza. So I want a poem about the importance of pizza in modern society. So it is very much fascinating to see how a poem is written on pizza. A circle of dough, a canvas of cheese, topped with delights that please. Wow, it's good, right? Now let's explore about the temperature. Temperature controls the degree of randomness in token selection. So higher temperature results in higher number of candidate tokens, whereas the lowest temperature like 0 results in greedy decoding. So let's start with this. Here I have generated with the temperature 2 quite higher compared to temperature 0. So here you can see randomly color is picked up like indigo, blue, purple, etc. Whereas if you check out the output where I have set the temperature 0, it is a worst response. You can see the same color is picked up again and again. So this is the way how you have to play with the temperature to generate the randomness. Next we'll come up with top K and top P. These are the parameters that controls the diversity of models output. Top K is positive integer that defines the number of most probable tokens for which to select the output token. A top K of 1 selects a single token, whereas top P defines the probability threshold that once cumulatively exceeded, tokens stop being selected as candidates. A top P of 0 is typically equivalent to greedy decoding. And similarly, if it is equals to 1, every token in the model's vocabulary is selected. So check out over here. So top K I have taken 64 and top P is 0.95. So you can check about the same pizza. So you can see the story, right? Check out the story, how it beautifully it has written. Pepperoni Pete was no ordinary pizza. He dreamed of adventures beyond the confines of the cardboard box, beyond the warm, cheesy embrace of the delivery bag. It's completely amazing seeing an AI being a creative writer over here. Let's go with the different prompting. So the 0 short prompt are prompts that describe the request for the model directly. So check out over here. So these are the basic models which I have already defined. So my prompt says classify the movie review as positive, negative or neutral. So here the review is given and you can see I have received a positive answer, right? So if you see, the review is actually indicating a positive sentiment. Whereas NM mode, if you see, it is similar to the object oriented NM. So in this section you can see we have generated an NM, positive, neutral and negative. You can add how much NM you want as per your requirements. So the same response I have selected it, so you can see it is positive. So for positive it is positive. Let's move on with one shot and few shot. So providing an example of the expected response is known as one shot prompt. When you provide multiple examples, it is a few shot prompt. So you can see I have provided a multiple examples over here in JSON format. So when I give me a large with cheese and pineapple, so I am getting the size as large, type as normal and ingredients are cheese and pineapple. The same way next, if you check in the JSON mode, so I have given the prompt as can I have a largest dessert pizza with apple and chocolate. So here I have said the size, ingredients and the type. So ingredients are apple, chocolate, size is large and type is dessert type of pizza. Let's move on with the next, that is chain of thoughts. Chain of thought prompting is a technique where you instruct the model to output intermediate reasoning steps and it typically gets better results, especially when combined with few short examples. So check out over the prompt here. When I was 4 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? So as you can see, 8 years difference. So check out over here, when you are 4, your partner is 3 times age. So obviously your partner is 12 years old. And the age difference is 8 now, right? And the same way now if you are 20, obviously the partner will be 28-year-old, right? He will not be 3 times. It will not be 60. It is 28. This is the logic applied. So in the next prompt, if you want to know exactly how the logic is applied step by step, just include the prompt over here. Let's think step by step. Just check it over here. The step-by-step manner, the explanation is provided. So check out the third one. The age difference remains the same. Since the age difference never changes, your partner is still 8 years older than you. Next, let's discuss about the React prompt. So it will help us to do the reason and act. Okay. So here you can check. There is already a Wikipedia page for React. I'll highly recommend you to kindly go to that page and view the different examples which is available over here and try all the examples which is over there to have a better idea of what these prompts are and how they are gonna work. Here you can see the model instructions I have given over here. So exactly what it has to do, when it has to search, when it has to look up and finish. And some of the examples, questions, thought and actions. And also the observation is provided over here. So once this is done, I would like to give a question to my LLM. So who was the youngest author listed on the Transformers NLP? Okay, so here if you see, I have not given any thought. So check out how the LLM responds. I need to search Transformers NLP paper because we have not said which Transformer paper, right? So to find the author list and then determine the youngest, right? So action will be what for that? It will be checking Transformers NLP paper. So this is the search action. Whereas I have tried to give a different observation. Attention is all you need. So these are the set of people who have written the white paper, right? Which you have seen. So now if you check, the paragraph obviously doesn't mention the age. It just mentions the author's name. So it has to search for the individual author's age. So it will start from Ashish Vaswani and then it will continue ahead with Noam, Nikki and so on. So let's just move on with the code prompting. The first is generating code. So in this section you can see the code prompt which I have written is write a Python function to calculate the factorial of a number. No explanation, provide only the code. So here you can see only the code is given in the Python language for calculating the factorial. Okay. Here is code execution. So in case if you want to execute the code of the respective prompt, so calculate the sum of the first 14 prime numbers. Only consider the odd primes and make sure you count them all. So check out the output. So it has identified all the prime numbers and then it has added and the final output of 328 is presented to you. So next, if you want to look into the responses of the output which is provided by the LLM by part, you can check it over here. So it has done the executable code and then the output is obtained and then the text is displayed to you. And that wraps up today's deep dive into the fundamental large language models and text generation and prompt engineering white papers and also the code of prompting. I hope this breakdown has given you a clear understanding of these powerful tools and how you can start leveraging them effectively, whether it's for refining prompts or exploring practical applications. If you found this helpful, please give it a thumbs up and don't forget to subscribe so you don't miss any of the upcoming content in this 5-day Gen AI intensive series. If you have any questions or need clarification on any of the points we discussed, feel free to drop them in the comments. I'm here to help you. Thanks for watching and I'll see you in the next video.